Welcome to another episode of I Peel Onions with Hammers. Today I am joined by Zack.
Hello.
And Dylan.
If you can hear me.
I can hear you just fine. It was only about an hour and a half of troubleshooting on two of our ends. Zack has it working perfectly.
I mean, I ain't been on in like 2 months, but, you know.
Well, you keep it fresh, keep it preserved.
Gotta keep it updated.
All right. So in the spirit of what I tried to do and failed miserably because I realized that I can't do these without people, it's hard to do these by myself the way that I wanted to do it. I have something for you all. I have a question. Are you ready to receive my question?
Hit me with it.
I want to know if we can figure out a way to time travel. I want to go backwards or forwards in time. Can we do it?
What makes you think it hasn't already happened?
That's a very good question.
I'm serious, because if you look at it this way, if time travel hasn't already happened, the reason why we don't have proof is because it's already succeeded. Why would they need to come back if they've already altered it?
I mean, that's 100% true. How would we know? Maybe that's what, like, you've heard of the Mandela effect, right?
Exactly.
Exactly. Maybe the Mandela effect is actually folds of time and universe and space that were there, remnants, and then we just can't figure out why.
Yeah. Because we were going on about it the other day about, what was it? It was some kind of biscuits or something. The name of it, though, it was like completely opposite of what it was supposed to have been. And it's like, no, everybody remembers it being such and such. And there's no traces of it anywhere. You can't find it anywhere on the internet or otherwise.
Do you all know the ideas behind time travel? Like, what people suggest, the only way that we can do it. Do y'all know the actual idea behind time travel?
Are you talking about like as far as like Back to the Future wise, or the actual theory of time travel?
Well, I mean, I guess just the theory of time travel.
Well, there's multiple ones. You've got wormholes, the actual acceleration of particles.
Hold on, Dylan, I can barely hear you.
Can you hear me now?
Yeah, but you're just so quiet.
Unless, well, no, like I know there's a couple of times that I was trying to say something,
Okay,
but got distracted.
I was just curious because, like,
but I know the wormholes. I know technically with the wormholes, it's the most common one.
That's
because the World War II pilots, they've encountered a lot of these wormholes, and there's like a bunch of documentaries that they got or that I used to watch. And in the Bermuda Triangle, there are, I guess, speculations of like weird stuff that's happened to these planes that's caused them to crash, or that's caused, boats to sink in the ocean. But most generally, it's airplane.
I was leaning towards wormholes. I've got a formula up here for time, but the dilated time or whatever. But the idea, and I think it was Einstein that said, actually, this was not just time travel, this was space travel, like distance travel. If you really want to go longer distances, you would need to fold time and space in on itself, and then you could just cross through. So the idea of time travel is to open up a rift in reality, pretty much, time as we know it, our reality, and step backwards or forwards in time.
And here's the fun part about that. So what happens to the energy after it's released? Because you're going to need a lot of energy in order to do that.
Yeah. Well,
because
yeah.
It just doesn't dissipate and go with you.
Almost atomic levels of energy.
Well, that's how if you look at most video games nowadays, that's how they explain their space travel is how they're jumping from light years. All right, here's a good one. So Halo, when their jump drives, when they go off in the cities, it's literally like nuking the city itself.
Right, yeah.
Yeah, because all the forces behind it when they take off, or because it's got to accelerate at such like a high rate of speed just to get it to go.
Exactly. So if you're going forwards or backwards, I mean, it's got to go outwards.
This goes back to what Zack said earlier when we first started here. Who's to say that it already hasn't happened? And an example of that, I go back to Einstein, who helped create. Who was the other guy he had the famous quote? Something about "I have become death."
That's the maker of the nuke. Hang on, I can't remember his name.
J. Robert Oppenheimer. They created the atomic bomb. So we're talking about you need enough energy. You need enough energy to travel, to bend time and space itself. Who's to say that we didn't do that when we created the atomic bomb?
Not to mention, why would they need to test it conspicuously over and over and over and over? And then all of a sudden they're like, nope, we've done enough testing. We found everything that we need.
Yeah, just end it. You know, like in Half-Life.
And then
yeah, go ahead.
and then they stop everybody else from doing it too.
What did they find?
Exactly. Or what did they see that they didn't want others to see?
Oh, good God, yeah. Yeah, and you know what? Funny. So this all happened, when was it that Roswell, the events of Roswell, New Mexico? Okay, the Roswell incident was in 1947. When was the atomic bomb invented? 1945. So, the atomic bomb was July 16th, 1945. He was ready to test the first bomb at the Trinity site near Alamogordo, New Mexico. And then in Roswell, New Mexico, 2 years later, we have the Roswell incident, which a lot of people associate with aliens. You all have played Half-Life, right?
Yeah.
You know when they cause that incredible surge of energy to rift through a portal, they open up a different realm to these alien creatures. All I'm saying is, I don't believe in coincidences. Maybe these people didn't figure out time travel. Maybe they figured out a way to cross the rift into something else.
Or something else picked up on it and crossed into them.
Very true. That's a lot of energy released all at once. And
you can't tell me that you can't pick that up on some kind of scanner somewhere.
Something. Or let's say someone's living their best life on alien land, right? And then all of a sudden the sky opens up and it's like, what the hell? It just opens up, right? I don't know. Like maybe that's why it just abruptly stopped. However, since then, since the creation of the atom bomb, we've got nuclear bombs that are way more powerful than that.
Well, it's not even that now. You've got stuff that literally can travel at the speed of light that will deal damage. You've got fusion reactors.
Did you say dild damage?
Dildoed.
Oh, man. What are your thoughts, Dylan?
I don't want to be the downer of the group, but I mean, in a sense, it does seem like it would make perfect sense when it comes to like the atomic bombs.
Yeah.
After obviously like with the detonation and everything, that it could cause the energy, but I don't think it would be necessarily enough.
Well, it may not be enough, but what says that there isn't something in there that mixes along with it?
I mean, it would take more, I would think, just because all right, as humans, we do things to see how far we can push limits. Granted, being the atomic bomb being one of them, but with the invention of the atomic bomb, the reason why it was made was just because at the time it was made to basically stop the war. I can't remember exactly from what I seen or from what I read from the documentary itself at the time. But with that being said, I think at that time, it obviously it leveled, like, I guess, cities, kind of like how, like, when Zack brought up on Halo, on like when they did the light drive or whatever. I would think if anything would have, like, if something was to cause an incident like that, it would have to be more of a focused point instead of it being like leveled out. It kind of like putting water in a bowl instead of on a plate, if that makes sense.
The atom bomb itself is you're splitting an atom. You're splitting an atom with all that chaotic energy, which is the smallest particle, the smallest that you can get. And it contains, what is it, a proton, a neutron, and an electron? One atom?
Yes.
Right? So you're splitting the nucleus of I think I'm saying it right. So you don't get any smaller than that, and that kind of causes a chain reaction that causes this giant explosion. So what I'm getting at is that you're literally going to the smallest particle in the universe. And so what I'm proposing is that if you are splitting the smallest particle in the universe and it says, what the fuck, and it opens up, I don't see how that wouldn't open up some kind of hole in the universe. I want to say wormhole, but you see what I'm saying?
Yeah, if it was to open up a wormhole, then it would have opened it up on the ground. There's been some things that's happened that were the nukes or the bombs that's been dropped were opened up in the sky, where pilots have basically, I guess, ran into the wormholes when they were flying, and they traveled like further distances. Oh god, I can't say it. They traveled further than what they originally intended. But with the wormhole aspect, if that was something that like if it would have came around to it, let me say it like that. If it was something that happened, it would have happened on the ground instead of in the air. Like I see where you're coming from with it, because like with the atom splitting and everything.
Okay, so let's back up for a second.
Okay.
Let's talk about wormhole theory in itself.
Okay.
Wormhole theory in itself isn't just about space travel. It's also about the time travel, obviously.
So yeah, like it's long distance, but in a short time.
But they also thought that it could connect to multiverse theory, as in it just doesn't transport you to somewhere in our own universe, but could be in a completely different universe.
Oh, that's very true.
So it may not be here,
but
it could be here in a different universe.
Which brings me to something that I've spoken about before. Okay, like I've talked about how there are particles out there in space. I can't remember what they're called. Is it dark matter? Something like that. That is, it's been going out, and then all of a sudden you've got matter. You got particles that are coming inward. And I thought to myself, well, let's say, because that's chaotic energy. Dark matter is chaotic energy. Let's say that is coming back into a centralized point, and then if it all comes together, let's say that creates a massive, dense, like a star, when it just and then just explodes, and you would have like a Big Bang theory where the energy would just be expanded. So that would be the creation of the universe all over again. My question was always, how do we know that this is the first time that our universe has been created? And how do we know that whenever these events, these potential Big Bang, my idea, how do we know that whenever that happens, it doesn't delete the universe, but puts it on a different plane of existence? And so...
Now that makes sense.
Exactly. So with wormhole theory, like you proposed, if we could breach through space, time, and reality, we could not only go back in time, but we would go to a time that may not necessarily be in our reality or in a different realm. It's very confounded.
And here's a fun thing about that one. Okay, so say multiverse theory is true. All right. Say time travel's true. Say you time travel. You think it's your own universe. You time travel to a universe that's exactly like that, except the choice that you just made doesn't exist. You get what I mean? All right, so let me dumb it down. So you're playing a game that has story choices. You create a save file right before you're about to make an important story choice.
Oh God, it's one of those.
Well, yeah. I mean, I usually do, yeah.
Put it to as in multiverse theory versus time travel.
It's kind of like an autosave.
Like, okay.
Right before you die, you're in an infinite death loop.
Yeah. Except on this point, you time travel to make a different decision, to go back to fix a thing. Instead, everything past that point has happened in the universe that you just time traveled to, but it's not the universe that you're in. So you fix it, and then you time travel back to your own universe.
Oh, Doctor Strange.
Oh, God.
Or DBZ Future Trunks.
That is true. I forgot all about that.
Because he time traveled multiple times to try to fix his own and couldn't fix it. So what puts it to the point of what if we actually did figure out how to time travel and it would work like that?
Well, the only thing that I'm kind of curious about, because again, like if you actually like, all right, for instance, like World War II pilot wormhole encounters, there's actually videos and stuff that you can look up and watch because they've encountered them before. I haven't seen anything recently from I'll say at least from like 2000, right? 2000 all the way to 2021 that anybody has encountered a wormhole, but it was all back then around obviously the time of the detonation of all the bombs.
Well,
Think about it.
It's hard for us to get any real news lately because the internet's so controlled. The news that we find out, the things that we find out now, like if we were to, like, okay, back in the Spies or whatever, you remember how in movies of the spies or the hero would be like, oh, I've got this information that's going to save the world. And they're like, oh, we got to take it to the press, alert the world. If that were to happen today, people would be like, well, where's your sources? What's your facts? Are these facts? This is fake news. Like, oh my God, I'm just trying to save the fucking world, you know?
Fun fact, actually, when I was in ROTC, I had a colonel that was from the Cold War era. He was actually in intelligence, and to this day is still not allowed to talk about some of the things because it's still not decommissioned as far as declassified.
Oh yeah, I forgot about that.
But people are just interested in more modern stuff, and it's like, no, you kind of want to look at what's happened before you go and catch up.
Yeah, exactly. I'm not interested in all these pseudo, these neo. What am I thinking of? These all these things on gender studies and stuff like that. It's like, can we stop thinking with our nogs and think with our nogs? If you know what I'm saying. I want to go work for Elon, and I want to go to space. I want to do something important. But now look at the look at the DeLorean. The way that was created, that idea. We've always thought about it, but that all comes back to the energy idea. There is a lot of energy to time travel. Can you imagine? Can you imagine having a car that would run off of garbage that would go back and forwards in time?
I mean, it's
pretty close, but as far as going back in time, that would be amazing.
I mean, it's not too far-fetched, though, when you think about it. If the technology is there, the theory is sound, all you would need to do is get the equations right.
Well, yeah. I mean, yeah, like what kind of... Okay, let's think about this for a second. I've always been fascinated with the idea of hydrolysis, which is turning water into usable hydrogen energy and using it as a fuel source. So imagine... well, I mean, like steam, but okay, if you take water and you find a way to evaporate it into steam, what you're doing is you're changing the chemical properties of water from H2O to H, and then O. You're splitting the
and then,
go ahead.
I was going to say, and then if you compress it, it really, really puts off a lot of power.
So basically like splitting atoms, is what you're trying to say. Yeah. That's what I'm getting at. Yeah.
Then you create a really just a big combustible energy or flammable energy. I always get those confused. But now if you take garbage, all the chemicals and all the elements and all the whatever in garbage and you turn it into energy, it's the same thing. So it's like in that car was this motor that, or this whatever it was that was able to, let's say you took the elements of whatever and you split them down to their atomic form and then you created that type of energy. But why did they have to go to 88 miles an hour? I don't understand that. Like, that's the only catch?
So I was looking into more wormhole theories. And this, I thought of something. This is interesting. I'm not entirely, I'm going to butcher his name. Schwesterchild. His theory on wormholes, it was disproven, but here's a fun fact. If you think about it, if it's a one-way wormhole, wouldn't that technically be a black hole? So nobody's been able to obviously survive a black hole for being crushed from it. Except they believe now in theory, if it's a supermassive black hole, you're able to go in it without dying.
They went through a black hole, let's say 20, 30 years ago with the technology that they had then. How would have the plane survived?
Well, that's what I'm saying, as in...
How would we not have felt it?
Well, that's what I'm saying, as in maybe something did go through it, or something happened and it caused it, or that's the universe saying, hey, it's possible on larger scales.
Wait, so you're saying that somebody, like a person on this planet went through a wormhole? When did this happen?
No, I'm saying as in, they believe in theory that you could survive a black hole if it's massive enough and the event horizon doesn't tear you apart because of how it's so big.
Right.
So in theory, you could go inside and study it. Obviously, it's a one-way trip. All right, so think about it this way. If it's a one-way trip, it's got to spit you out somewhere. Because if you think about it, if this guy's theory is right on a one-way wormhole, that would mean most black holes are wormholes.
Yeah, but like for the bigger black holes, though, for instance, the gravity that's inside of it that creates this black hole, it's pulling everything apart instead of actually, I guess, trying to like synergize it. If I'm actually saying that correctly, actually, like going into a black hole or going near it, it will destroy anything. The smaller ones, I don't think it necessarily would.
No, it's the exact opposite. The bigger ones won't. It's the smaller ones that will. So when you're flying into an event horizon on a black hole, it's not the pull of the gravity that is necessarily going to crush you. The gravity can be much more resilient to yourself if the black hole is bigger because it doesn't take as much to pull you in. You get what I mean?
Mm-hmm.
Yeah.
I'm actually looking up black holes right now. I'm trying to, because what I'm thinking of, the reason that black holes have so much gravity is because they're so dense.
Oh my god!
And
your audio just went completely haywire.
me? Is my audio bad?
Yes. Oh my god!
Real bad?
It like a robot.
It sounds fine on mine.
Oh god.
All right, wait. Just go ahead and continue.
Okay.
Yeah, you're good for now.
I was just looking up something about black holes, and that I know that in order for something to have so much gravity, so much pull, it has to be densely packed. However, the black hole, what is it so densely packed with? I'm looking here that light can't escape it.
Yeah.
And the event
That's
horizon
what
is what is the boundary of no escape. Like once you get to that point, it's over. Done. I just like I think one of you said it has to go somewhere. Like it can't. Oh well, or can it? Because it has to be dense somehow. So what is the point? Where does that? Where does where does it go?
That's what I'm saying. Because if it's continuously sitting there eating everything around it, including light, and it's getting massively bigger, wouldn't eventually it end up like a sun itself and go through a second dying phase once it runs out of things to eat?
Well, if the first dying phase, I don't know. I don't think it would necessarily.
And here's a bigger one, because black holes can actually combine together. That's something else.
I've heard of that too.
It sounds like what is it, like the twisters making like
the
more
mega
of
twister,
a devastating. Yeah.
the mega black hole. God, that sounds like a bar.
That's whoa. I mean, that's not. When we going to go to Skinamax here, or
it's like a bar, and also associated with the toolbox. I'm just saying. I'm actually looking at it right now. It's I guess it would be pronounced Schwarzschild. I can't say it. I'm looking at the simulation of it, and it's just like in those things you see on TV where they got like a cloaking field on a ship. That's what it looks like when something's passing over this black hole, like a fisheye.
Yeah. And say that's something else. We just recently have been able to actually see black holes. That's not been around for like, I think only the last 20-something years.
Oh yeah, because now we got like better technology to actually understand it.
Well, I mean, you know, it ain't our fault that somebody forgot to put a fucking lens in the Hubble telescope.
God, how old is the Hubble telescope? Let me look that up.
It's old. It's starting to fall apart, actually.
I think
that's the one where it's got a whole building that's built underneath this thing.
Is that what this is? They had a scare recently, and they had to turn it off and on again. They got it back to working.
So they just need look with all the money America's got. They could easily.
Oh wow!
31
so
years.
It makes a full orbit every 97 minutes.
That's insane. That's fast.
That is fast.
Wait.
I'm telling you, you would die going in this thing.
It says it travels 5 miles every second.
Wait, hold on a second. Are you talking about it rotates, or are you talking about that's how fast it's going right now?
It's the rotation of it.
Yeah, the Hubble Space Telescope.
Right.
Like it's spinning. It's spinning around,
or
no, like it's orbiting Earth at 5 miles an hour.
Oh Jesus!
Wait,
Christ.
I think talking about the black hole for a minute.
No.
And I don't mean like 5 mph. I mean like literally every second it is passing at 5. It's passing 5 miles.
Well, it's so far from
Wait,
because it isn't going the opposite rotation of the Earth.
Hold on. I thought
is it going with or is it going against?
I thought the mission of the Hubble Space Telescope was to go as far outward as it can, away from the Earth.
I thought this thing was on the ground. I didn't know it was actually in the.
Well, there's two. That you got the one that they built on the ground, I think back in the 70s.
I know it's 31 years is his mission.
All right. So again, what I said earlier kind of stands. They could build another one because if this thing goes out, all these people in there are probably going to die.
Oh yeah.
Like, there's no turning back.
Oh yeah, yeah. It's at Earth. I thought they had one sent out that was like, what am I thinking of? Going outward.
What, like a probe?
Something like that. Yeah.
Oh, that's another interesting thing. Oh, Voyager 1. It's was launched on December 5th, 2011, and to have reached the outer edge of the solar system and entered interstellar space on August 25th, 2012.
Oh wow. Whoa. So in 1 year, it managed to get to the edge of the solar system?
Yep.
What kind of speed was it going? Jesus.
38,000 miles per hour.
That's a lot of G-force.
Well, see, that's the thing about space. Go ahead.
It's currently 11.7 billion miles away from Earth. And that was back in 2013.
Oh God, I'm looking at something right now. It cost $250 million to make in 1977. And it's going 17 kilometers per second. So
if anything can time travel, it's that damn thing.
That's just it. See, that's the beauty of space. Space. Once you get into space, it's Newton's laws of gravity. You will go to the same speed unless acted upon by an outside force, and we can understand that because we lived on this planet all our lives. But if you go into space, you can't stop until something stops you. So imagine being this Voyager going past these planets with much denser. They're denser planets, and they're able to produce way more gravity than the Earth. So the Voyager is going by them and getting some of that gravity, but skimming off of it. Let's say, I think they did this a couple of times. I think that they went around a planet like a Saturn, and they went around Saturn's gravity and got some of that slingshot. They slingshotted it. That's it. I think they did that. That's how come it's going so fast right now.
Oh, this is creepy. So this is back in May 11th of this year.
Mm-hmm.
It's at 14.1 billion miles away from Earth right now. It is now in interstellar space, but it hears an ominous hum.
Yeah, I remember hearing something about that. Actually.
Oh, God.
14 billion miles. Still going 38,000 miles strong.
Basically, something's going to be coming here. It's going to take a while.
Well, they said in about 40,000 years, it'll hit a sun.
40,000 years.
40,000 years, it'll hit a sun. See, that's one thing. Like, for instance, like Star Wars, Star Trek, whatever. Like, using warp speed, light speed, whatever. Like, jumping.
Mm-hmm.
Or, like, jump speed, what have you. In order to get to your destination safely, you would have to angle it, like, pretty precise. Because if you're off by the slightest, you're going to go straight into a planet.
Yeah, actually. Like in Mass Effect, the Mass Effect relays. They can't jump into that fast of a speed without the relays.
And you just don't see it coming. Literally, you'll just run right into it. Boom. Dead.
Or
I mean, you got to do it like Han Solo. He made the Kessel run in 12 parsecs.
That man is a fucking legend.
That's my fucking hero.
You know, and the idea of traveling in light speed, okay, if you look at that Schwarzschild, I can't say his name. I swear, I don't even know why I try. When you look at his little diagram, you see the cloaking field of light around the black hole, the event horizon. That's what light speed looks like on the movies. Light is literally bending because you're going light speed. How do you recover from that?
Yep.
You know?
You just don't.
You just don't. That's it. Now, I was actually...
Well, here's the fun part.
Yep.
So they've done... what the hell is it? They've done physics engines of like what would happen if even a tiny speck of dust of light speed hit the Earth. Mm-hmm. It would literally vaporize our atmosphere in less than 5 seconds.
Wait.
So if there was something out there going light speed and it hit us, it'd kill us.
Well, hold on. What about the sun?
Words,
I'm talking about matter, like a speck of dust, as in something that, that has an atomical,
has some weight to it.
Yeah, some girth.
girth.
Yeah, because force force equals mass times acceleration. So if you're going light speed and you weigh 0.000001 gram, you're going to cause some damage.
That's a lot of damage. Like, if you're just, like, let's say, you're in an X-Wing, all right? I know it's a little bit bigger than a speck of dust. Would that mean you would just take out at least a portion of a continent? Obviously, you would just shatter the atmosphere of a planet. If you actually hit the ground, what kind of devastation would that cause?
Wait a minute. So you're saying a spaceship going light speed, hitting the
just
landmass,
nails the planet.
Well,
because it wouldn't have time to evaporate.
I don't know.
Because if a speck of dust can do that, and it would just destroy the atmosphere, then what would like a larger, like a mobile home, for instance, in space, light speed, boom. Like, I'm curious now.
Well, how would it stop?
Well, considering that the asteroid that killed the dinosaurs was approximately 6 miles in width, hit the Earth going less than that, and it wiped out an entire species. Okay, so the asteroid that killed the dinosaurs was 6 miles wide, right? That was traveling far less than the light speed.
Oh, yeah.
Somebody was telling me the other day about the T-Rex specifically for the dinosaurs.
What, that it's fucking related to the chicken?
No.
Oh.
Other than that. But basically, he claimed that the T-Rex, obviously, like, it's got... Okay. It was a massive creature. All right. But if it was related to the chicken and the arms, all right, it's got small arms for, like the hard bones. What would be something as like let's pretend like it had wings. All right.
The T-Rex?
This big ass chicken.
Oh.
Yes.
Oh, God.
I mean, that's not too far-fetched considering that raptors had feathers. I mean, it's not too far-fetched. We can't correctly anatomically probably make up what they actually looked like.
Yeah. Because like the bones from the T-Rex, the skull is hollow, like a bird, right? So, and the arms are shorter than most of the creatures that were obviously then in that time frame. So, with that being said, this thing was a flying predator. It has to be. Obviously, there's no proof to entirely show that this thing had wings, but it relates to the dragons in a sense, but without the fire breathing. These were bigger than pterodactyls.
This is very interesting. And I say this because...
Yeah.
Well, I've got something here. You know how when we die, our noses are just cartilage, so they just disappear? Who's to say that the reason we don't find any wing bones on the T-Rex is because it was just cartilage that disappeared?
So our entire childhood is a lie with Jurassic Park. Those bastards. I want my money back.
It's all a lie. This is why we need a time machine.
One ugly motherfucker.
That's exactly why. That is exactly why, because they would be one ugly motherfucker.
I mean, you're not wrong, but again, it's still something that, like it's there and it makes sense. Just because they said that its head was hollow.
No, it wasn't even a resemblance. It's literally they can actually take the DNA from a chicken and test it against the DNA that makes up the bones from a T-Rex, and there's some kind of connection there.
Well, I mean, there's also a big connection between us and a banana. I want to say 60% DNA.
I mean, we're what, fucking 80% water?
Yeah, we're a lot of water. I don't know how much. Is it 70, 75? It's close. It's close to that. Very close. 60%. Bananas and us, we share 60% of DNA with it.
Wait.
I mean, think about it. We all come from the same planet, allegedly.
Where the fuck did y'all even see this from?
It's right there. It's on the internet, and we all know the internet doesn't lie.
That's a lie. But okay, if we are 60% of this fruit, all right, like how? So basically, chickens have devolved, so humans or bananas could rise.
Listen. Hold on. Let me go back to the asteroid for a second. When that asteroid hit, it didn't just hit and cause like chaos or whatever. I've seen this. Like if you play one of those universe simulators, let's say you throw a big giant rock at a planet. You know what happens to that planet? I'll tell you what happens to that planet. That planet gets red hot. It gets red hot, And maybe that planet was, I don't know, spinning on a perfect axis. Then you have a rock hit it and tilt the axis and then turn it red hot. You know what I'm saying? So after the planet cools down, which could take 100 million years or longer, that whole surface of that planet's going to change. It's wild to think about. Really wild to think about.
And something else I kind of think about. Apparently, they're thinking that obviously, like underneath the crust of the Earth, they don't think it's actual lava. They think it's water.
I've heard of that. That's also is it Jules Verne?
I can't remember who it was that I seen it off of. It was from like one of those short videos. It kind of caught my attention, but it makes sense because scientists have dug way past, or they supposedly dug so many feet into the Earth's crust and has found like a different lake or like a different, like, I don't know, it's like a different source of water basically.
It was,
and it's got different oxygen readings, I guess it was. Which to me it doesn't necessarily make sense because if like the Earth did all that, like obviously it did, but like after the asteroid hit it and then caused it to go glowing red hot, melt everything, and then just kind of like slow down for Earth basically to kind of repopulate itself to give life. What's to say there's not, like, if there is water underneath the crust of the Earth, maybe there's some stuff down there that we haven't encountered yet.
Well, it's not even that. We still can't reach the bottom of our oceans, as in there is still things that probably are in, what was the trench's name? The Mariana Trench?
Mariana Trench, yep.
We can't send a submarine down that far. The pressure down there crushes it.
Too much pressure. Yeah.
I'm telling you right now, I'm not going to be the brave soul that does it either, but
we have literally, I think they're digging a hole in Japan right now to see how far they can go for science. We have literally only made it halfway through the crust.
Just go to Russia. They already started that project. Finish on what they did.
Or was it Russia? You know what? It's probably Russia. I'm wrong.
Yeah,
You're right.
because they went, so I can't remember, but they started digging and apparently they hit water at some point.
What you described, Dylan, is when I mentioned Jules Verne. He's the man that wrote 20,000 Leagues Under the Sea and Journey to the Center of the Earth. And in Journey to the Center of the Earth, he describes exactly what you're talking about. Finding creatures in the mantle and a lake, dinosaurs, etc., etc.
Yeah.
It's an old book.
That's a lot of what people thought that they would find in, was it Antarctica or the South Pole? Like directly on the South Pole. I don't remember which one.
There's like some kind of bacteria and stuff like that they found in the ice. I think it was in the South Pole, from what Zack was saying. It's one of the two. Basically, they found some stuff and they're trying to pull some Jurassic Park shit.
What, trying to revive it?
But yeah.
Oh God, why?
No.
Why would you do that?
I don't know.
No. You want to release something worse than the Black Plague? Yeah, no.
That's exactly how you do it.
Obviously, ice is like the most, like, to me, it's one of the, I don't know, like it can preserve cells, DNA from many, many, many years ago. Okay. Well, if that's the case, and what Drew said recently, that it was glowing red hot, then how is this still there, but in ice form?
I don't have an answer for that. You're talking about events that, like, we can't even fathom how long it took. This is just theories, but let's say that did happen. We got hit. Earth was red hot, spinning super fast. We can't even fathom how long it would take for that thing to cool off, shape, keep it cylindrical, or not cylindrical, sorry, a spherical shape. We can't even fathom the hundreds of millions of years that have passed for that to happen. So when it finally did cool off, who knows? Because it wouldn't have an atmosphere just yet, right?
Well, yeah.
Who knows? So I'm gonna reel this back in. So if I wanted to go back in time, what we've discovered is that first of all, I need to go down to was it Hibbett Sports? I need to go to Hibbett Sports and I need to get the best football just armor that I can find because it's going to rip me to shreds. And I need to find a way to get an atomic bomb, put it in my car, and blast off.
Yeah.
That's it.
I don't think it would work.
What do you mean you don't think it will work? What a f***ing downer. What the f***?
Because it's something that I could say that it's impossible. Because first of all, garbage, we burn it for fuel as it is. But I mean, it would have to be a lot. And it would have to be compressed to make this immense amount of fuel for this vehicle to project itself at a high rate of speed.
I didn't say use garbage. I said Christopher Lloyd used garbage. Doc Brown used garbage. I don't want to use garbage. I want to use helium, actually.
Helium.
Helium is what I mean. Helium is super flammable. Very flammable.
Apparently helium, we're running out of helium on this planet as we speak.
Oh, we can get that from another planet. Which one? Which planet? There's a planet out there where they have oceans of helium.
Mars?
Is it? No, it's not Mars. It's, I want to say, is it Neptune? Or, no, I think Uranus is pretty gassy.
Baba Booey.
Just don't try to get it from a cow's ass or you're gonna regret it.
That would completely caught me off guard.
All right, yeah. So that's what we need, Dylan. Dylan, we need to fill Uranus full and blast off. That's exactly how we're going to go back in time.
Nuke his ass.
So I think we pretty well covered this. I think that's all we're going to have for this week on I Peel Onions with Hammers. I appreciate you two joining me for this glorious space, time-filled, Uranus-filled episode.
No problem at all. It's been real fun.
That it has. It's been interesting.
Yeah.
Even though I can't get the things that I need to say out of my mouth.
Oh, well, I mean, it's
all right. We'll be getting it out of Uranus.
Oh, oh man. All right. Tune in next time for another fun-filled episode. Bye-bye.
What the